Okay, I'm going to talk to you guys about solutions in this section. The most important part of solutions is the math for figuring out molarity. Molarity is moles divided by liters. So you always have to figure out the moles. If you are given grams, you have to change from grams to moles using molar mass. And you always have to use liters. You can't use milliliters. So you have to change from, if you're given milliliters on the problem, you have to change it to liters. So that's the big thing to know about molarity. So the main things we're going to focus on in this section is molarity, which is moles divided by liters, and the dilution formula, which is M1V1 equals M2V2. So if I have a given molarity, I can change the molarity by adding more solvent, and that will dilute the concentration to a lower number. So those are the two equations you want to focus on in this chapter, molarity and the dilution one. So let's move through this section. So solutions are homogeneous. Once you dissolve the solvent in the solute and the solvent, and stir it up totally, it's going to look like one solution that's homogeneous, top to bottom, side to side. You're not going to be able to see any particles or anything like that. So the picture here is showing the solute, the solid, being placed into the solvent, which is the liquid. Usually that's the case, but not always. And usually the solute is the one you have the smallest amount of, and it's dissolving in the solvent to make a solution. The picture here is not a solution yet because it hasn't been stirred up. Once it's stirred up, it's going to look like a clear solution, a clear liquid, and you can't see the solute anymore. And when you get to that point, when it's all dissolved all the way, it's homogeneous and you can't see any particles, then it's the solution. So at this point, it's not a solution. This is the process of forming a solution. So solubility means that one molecule or ionic compound will dissolve and be in such small pieces that you can't see it anymore. And when that happens, you can look through the solution. You don't see anything. You don't see particles. It's not opaque anymore. That is solubility. And solubility depends on the molecular nature or the ionic nature of the solute and the solvent, whether they like each other. So polar things like sodium chloride will break apart into pieces and dissociate into water because sodium chloride is ionic and it has charges on those ions, and the water is very polar. It's got a partially negative side and a partially positive side. So the ionic will dissociate into the water. So those things are very similar. They have negative and positive sides to them. So those are like, they're alike. Those two things are alike. So we use this little phrase called like dissolves like. So polar things will dissolve in polar, and nonpolar things will dissolve in nonpolar things. So that's why if you get grease on your hands after you change your oil in your car, oil is nonpolar. And so you can take some gasoline or some oil and some other type of oil and rub that oil off of your hands, because the oil that you use to change your car, or the grease that's in your crankcase or whatever you're doing when you're working on your car, those are nonpolar things, and they will dissolve in other nonpolar things. So here's an example of that sodium chloride I was talking about. We've got a crystal at the bottom here of sodium and chloride. So sodium is the positive little ion and chlorine is the negative ion. And they're in a crystal shape because as a solid, they make this nice repeating pattern of positive, negative, positive, negative. We put it into the water like that picture showed at the beginning, And water has a partially negative side. The oxygen side is partially negative, and the hydrogen side is partially positive. So these are waters are attracted to each other. But they also, because of that partial negative positive side, attract the sodium and the chloride and make them want to break apart into ions. So at this point, their attraction is pretty strong right here, but when the water gets near them, then they will break into just their individual ions. So here's the chlorine, and the positive guys is sodium. So we have anion and cation. And after a time, entropy will take over, and all of this whole crystal sodium chloride is going to break into pieces and be dissociated and surrounded by water molecules. So that's called dissociation, when you have a ionic thing and then it's put into water, it dissociates into pieces. Okay. We can also have liquids dissolved in liquids. So ammonia is a liquid and water is a liquid. So this is all the cleaning products around your house have a lot of ammonia water solutions. Water is the solvent. We usually use lots of water in our cleaning products, and we put a little bit of ammonia in there. And so ammonia has a partial negative positive side to it, as well as water has a partial negative, partial positive side. And so they like each other because they're both very similar. And so they will mix up, and then we can have a solution of ammonia and water. Nonpolar things, like I was talking about, when you have grease on your hands and you need to remove it, you want to find another nonpolar solvent. So hexane has 6 carbons in a row, and it's carbon and hydrogen molecule. So carbon and hydrogen together are very, very nonpolar, don't have a negative or positive side to them. Paraffin is the thing that you see in candle wax. It's also very long, carbon hydrogen chain, and it is also nonpolar. So these guys will like each other. So you can put some candle wax. If you have candle wax spilled somewhere, you can grab some hexane and use that to dissolve it and remove it. So this is a nonpolar guy and another nonpolar, and they will mix together because they're both nonpolar. So like dissolves like. So temperature can affect solubility. And you know this, when you make hot tea or hot coffee, if the hotter the tea or the coffee, the more you can add sugar to it and dissolve the sugar. So for solids going into liquids, the temperature of the solvent is very important, and the higher the temperature, the more you can dissolve. But gases are the exact opposite, and you know that because if you take a soda outside and you're sitting outside in the heat in the summer, if you leave it out too long, it's going to go flat, and all of the gases are going to come out of it, all the carbon dioxide. So solubility of gases is the exact opposite of solids dissolving in water into a liquid solvent. So 2 different kinds of situations, when you have gases as a solute and when you have solids or liquids dissolved in other liquids. So if you have a lot of solute in the solution, it's called saturated. If you have less than that large amount, the maximum amount you can put in there, then it's called unsaturated. And we're going to talk about concentration, how to calculate it, and we're going to use a concentration unit called molarity. So molarity is the one I'm going to focus on in this class, but if you go into other fields, sometimes in medicine or in other fields, you're going to use percent by mass or percent by volume or other concentration units. In chemistry, our main one is molarity, so I'm just going to focus on that one and not have you worry about calculations for the other ones. Molarity is our big one in chemistry, so we're just going to focus on one of those. But you might see other concentration units in other fields if you go into other kinds of jobs. So molarity, my graphics isn't working too well, but molarity is, we use the abbreviation capital M, and it's molarity equals moles divided by liters, and you'll see that in the book. I'm sorry, my graphics not working. And there's 3 kinds of problems you might have to solve. You're going to be given 2 of those items, but you're not going to be given the third. So you'll either be given molarity and moles, or molarity and liters, or moles and liters, and have to find the third thing. So molarity is moles over liters, and remember it has to be liters. It can't be milliliters. So if you are given milliliters, you have to change it to liters. If you're given grams, you have to change to moles before you can start. So those are the things you have to remember. You have to have moles and you have to have liters. So here's some practice problems. If you were given this one, you would take 6 moles and divide by 3 liters, and you'd get 2 molar. 2 capital M is your answer. 6 divided by 3. 6 moles divided by 3 liters gives you 2 molarity. And this one is in milliliters, so you'd have to change that to liters, which would be 0.5 liters. And you're given 4 molar, so 4 equals X over 0.5 liters, and then you'd have to solve for X. And then this one is 3 molar equals 15 divided by X, because we don't know the liters. So that's how you'd set those problems up. So I'm not going to do mass percent with you because that is not as important in chemistry, but you might see it in other fields. And then the other one I want you to focus on is dilution. So dilution means that you take a concentrated solution and you make it less concentrated, you dilute it. So it's just like an example would be if you make some Kool-Aid for the kids and it's super sugary and it's too sugary, you don't think they should drink that, such a concentrated solution, you'd add more water to it. So you would dilute it. So it's not that hard of concept. You're just going to add more solvent, and that will make the molarity lower. You'll have a bigger volume because you add more water, but your molarity will be a smaller number. It will be less concentrated, less sugary. Okay, so we're going to use dilution. So M stands for molarity and B stands for liters. The nice thing about this equation, if they give you molarity and they give you milliliters, you can also have milliliters on this side. So that's the nice thing about that. It's kind of like the gas laws where if you had milliliters on one side, you could have milliliters on the other for the combined gas law. Same thing here. M stands for molarity though, and volume can either be in liters or milliliters, but you have to have the same unit on both sides to make this thing work. So this is the concentrated side, molarity of the concentrated solution, the sugary Kool-Aid, and the volume of the sugary Kool-Aid equals the molarity of the more dilute. This is the dilute side. The molarity of the more dilute side and the volume of the more dilute side. So when one goes up, the other one, so when you add more volume, this gets bigger, then the molarity is going to be reduced on this side. So you're going to have less sugary Kool-Aid. And here's some practice problems that you can try. And you can keep these in milliliters. And you're going to find out milliliters when you do this problem here because this side's in milliliters. And then Henry's law says that the higher pressure you add of gases over a liquid, the more gases will go into the liquid. So this is how they make nice bubbly sodas that you drink. They take the can and they press down a whole bunch of carbon dioxide over the top of the liquid, and then the gases naturally will be pushed into the liquid and stay in there, and then they cap the can, and then you have a nice bubbly can of Coke or whatever you're going to drink. Okay, so that's how they do it. They just press down all this carbon dioxide, compact it down there, and then it naturally just pushes down into the liquid. That's called Henry's Law. So when you open the can of soda, you'll hear that carbon dioxide whoosh out because it's coming from the liquid and coming back out because you've reduced the pressure. And this is important for our lungs. It is the basis of how our lungs work so that we can push oxygen into our blood and then let carbon dioxide out of our blood. So we use Henry's Law in our lungs and heart system. And then there's some other kind of mixtures that are a little different than solutions. Solutions are the homogeneous, and you can't see any particles in it. But there's other things that have bigger particles in them called dispersions or colloids and suspensions. So dispersions have like medium-sized particles in the liquid or the solvent, and suspensions have even bigger particles. And when we have light going through different of these mixtures, sometimes you can see it, sometimes you can't. But a solution, you can't see it. The light does not get dispersed. It doesn't get all over, it doesn't go everywhere. It just goes straight through. So this is a solution, but this one, the particles are bigger. So that's the Tyndall effect. You see that when you drive in your car and you have, it's a foggy night, you'll see your headlights just disperse all over the place because the particles of water in the air are pretty big. And when we add particles to a solvent, we can change the properties of that mixture. So if we have a lot of particles in our solvent, it's going to change the freezing point. It's going to make it a different temperature where that mixture is going to freeze, and it will change the temperature that that mixture will boil. And when we have particles in a solution, it also affects what happens in our cells and through the membrane of the cell membrane. And so that's called osmosis. So if the water amounts are not the same on both sides of this membrane, then water is going to move. So that's what happens in our cell membranes. We have semi-permeable membranes, and the water travels through the channels of that membrane. It's called osmosis. And so you can figure out that pressure that's between the different sides of your cell membranes, and that's called osmotic pressure. And so if we don't have the right concentration in solutions outside our cells, our blood cells, as they are inside our cells, we can ruin our blood cells. So it's important. That's why you have blood chemistry done. Like when you go to the doctor, you'll have your they'll take your blood and they'll check all these different levels. So if you have the right concentration in your plasma compared to the cell, then your blood cells are going to be perfectly normal and happy. But if you have too much ions in your plasma, you're going to shrink your blood cells. If you have not enough ions in your plasma, the water is going to go into the cell and can burst your blood cells. So we care about the concentrations of ions in your bloodstream, in your plasma, so that we can have healthy blood cells. And that's it for that chapter. So I hope you understand the two things that we need to concentrate are molarity and dilution, that M1, B1 equals M2V2 solution, dilution equation. So concentrate on those two formulas, and I hope you have a great day. I'll talk to you soon. Bye-bye.